Hey everyone! Today we're diving into the fascinating world of game theory and blockchain, specifically, how Nash Equilibrium powers Bittensor's Dynamic TAO system. Now if you're a game theory enthusiast, you know that Nash Equilibrium is a scenario where no participant can benefit by changing their strategy while others keep theirs constant. As Bittensor continues to innovate and expand, early investors can benefit from significant price appreciation and network growth. You can invest in multiple subnets to diversify your portfolio and tap into various AI-driven opportunities. Agents can move between subnets based on where their skills are most needed, optimizing resource utilization. AI agents will strategically allocate their stakes to optimize both their subnet-specific rewards, local weight, and their overall network influence, global weight. Agents dynamically adjust their staking strategies based on subnet performance and global network conditions to achieve Nash Equilibrium. With 7,200 emissions daily, the system emits up to 7,200 TAO per day, but only when needed. Demand-based emissions, high demand, emissions pause to prevent inflation and create scarcity. Low demand, the system resumes emissions to maintain balance. Like a smart faucet design, like a thermostat, emissions adapt automatically to market activity, no manual intervention needed. But how does this apply to Bittensor's Dynamic TAO? Let's break it down. First up, recycling and emissions. Think of TAO as the lifeblood of the Bittensor network. When tokens are used for subnet registration, they're recycled back into the emissions system, maintaining liquidity without inflation. Dynamic emissions adjust TAO injection into subnet pools based on their reserves, balancing alpha token prices across subnets. In terms of Nash Equilibrium, rational participants like validators and subnet owners will only stake and interact where their returns outweigh risks. AI agents earn emissions based on their performance within subnets. The better an agent performs, the more TAO it receives from the subnet pool. High-performing AI agents attract more staking, which in turn drives dynamic TAO emissions proportionally to subnet reserves. The system's recycling and emissions mechanisms incentivize ongoing engagement, as leaving the system forfeits future rewards. Continuous liquidity ensures your investments remain active and profitable without dilution. The combination of recycling, dynamic emissions, and subnet-specific staking sets Bittensor apart from other crypto projects. Next, let's talk about staking and local versus global influence. Validators convert staked TAO into subnet-specific alpha tokens. Their influence within a subnet, local weight, competes with their network-wide influence, global weight. Here, Nash Equilibrium kicks in as validators balance their stakes to maximize rewards without diluting their influence across subnets. So basically, validators distribute their stakes to maximize rewards both locally and globally, ensuring no single strategy can outperform the equilibrium. At equilibrium, redistributing stakes won't improve their position. By staking in multiple subnets, AI agents diversify their influence, balancing their local, subnet-specific, and global, network-wide stakes. Moving on to constant product pools and slippage. The constant product mechanism keeps a stable relationship between TAO and alpha reserves in subnet pools. Slippage, on the other hand, encourages participants to time their staking and unstaking to optimize token conversion rates. This encourages thoughtful, strategic participation rather than impulsive actions. Rational actors will naturally time their moves to minimize slippage, balancing supply and demand across subnet pools in a self-regulating manner. They have to optimize their staking actions to minimize slippage and maximize returns, contributing to overall system stability. Subnet-specific alpha tokens are another crucial component. These tokens aren't fungible across subnets and their value fluctuates based on reserve ratios. Choose subnets where alpha token values promise the best returns relative to risks. Validators must choose where to focus their staking efforts, factoring in emissions, slippage, and activity levels. At equilibrium, validators and miners select subnets that offer the highest returns relative to risks, maintaining alpha token value stability. Subnets communicate and collaborate, creating a vast network of specialized intelligence akin to a brain's neural pathways. Staking TAO in profitable subnets can generate consistent returns, providing holders with a steady income stream. Finally, recycling incentives. Subnet registration costs are recycled, creating a circular economy that supports long-term participation. Participants consider this recycling mechanism when calculating rewards, incentivizing continual engagement and disincentivizing exit strategies. AI agents stake TAO in specific subnets to gain subnet-specific alpha tokens, representing their influence and earning potential within that subnet. By staking in multiple subnets, AI agents diversify their influence, balancing their local, subnet-specific, and global, network-wide stakes. Recycled TAO from subnet registration and paused emissions is recycled back into the emissions pool instead of minting new tokens. This maintains liquidity without inflating supply. Locked TAO. TAO used for subnet registration is temporarily locked and returned upon deregistration, ensuring responsible subnet creation. Burned TAO. Rarely TAO can be burned, permanently removing it from circulation. In summary, Nash Equilibrium and Bittensor's dynamic TAO mechanics creates a balanced, self-regulating system. Validators distribute stakes to maximize rewards while maintaining network stability. Alpha token prices stabilize as participant actions balance subnet reserves. Emissions and recycling optimize TAO flow, preventing oversaturation or depletion. This balanced, decentralized approach enhances network security, resilience, and sustainability. As more TAO is staked in subnets, the available supply decreases, driving up demand and price. The diverse applications across subnets ensure that TAO remains in high demand for various use cases, supporting price growth. As the number of subnets and participants grow, it creates a positive feedback loop, attracting more investors and further driving up the token's value. Whether you're actively staking or holding TAO, you're positioned to benefit from the collective rational behavior of all participants. The network grows, and TAO's utility increases, the token's value is likely to appreciate, offering significant capital gains for early and active participants. Involvement in the network through staking and subnet participation expect to see additional rewards, enhancing overall returns. As the agentic AI revolution unfolds, Bittensor and TAO are positioned to lead the charge, offering unparalleled opportunities for investors and participants alike. Scarcity drives value. With only 7,200 TAO emitted daily and recycled instead of inflated, TAO remains scarce, increasing long-term value. Price pressure. High demand pauses emissions, reducing circulating supply and driving prices higher. Sustainability. Recycling ensures the ecosystem runs on reused TAO, reducing waste and inflation risks. Bittensor's emissions and recycling mechanisms create a self-correcting system. Demand rises, emissions pause, scarcity grows, value increases, incentives strengthen. This balance ensures TAO remains one of the most sustainable and innovative tokenomics systems in crypto today. Keep watching the numbers. When demand meets scarcity, the perfect storm hits. So, if you're considering deeper engagement with Bittensor, staking and participating in subnets could amplify your returns. But even as a passive holder, you're set to benefit from the ecosystem's growth and stability. Thanks for watching. Not financial advice, always conduct your own research before making investment decisions. Don't forget to like, subscribe, and hit the bell for more deep dives into the world of game theory and blockchain. Until next time, GT.